Hello and welcome to activity 3. In this activity, we are going to work on 3 lessons, 3-1, 3-2, and 3-3 this week. So we're going to be working with operations with rational and irrational numbers. Basically, we're going to be working with radicals. And so our learning targets for today are going to be to both add and subtract radical expressions. Okay, so we'll learn all the rules for doing that and putting things into simplest form as well. So I'm going to skip over the word problems. These are things that are great to do when we're all in class together, but for our recording, I just want to go over the basics for adding and subtracting the radical expressions with you. So I'm going to jump down to the example and point out a couple of things. So when it says to add or subtract each expression and simplify, basically we want to look for like terms. And so if you look at the rule above here where it says addition property of radicals, notice that you're taking a root b plus or minus c root b. They both have root b. And when they both have root b, you could just add the coefficients. So it becomes a plus c or a minus c times the square root of b, where b is greater than 0. Because remember 0, it's greater than or equal to 0 because you can't take the square root of a negative number. So if we were to look at a couple examples they've given us, we can see some like terms in here. So like in example A, I see 3 root 5, and I want to add it to 7 root 5. So we add their coefficients, 3 plus 7, we get 10 root 5. And that's actually in simplest form. Now, square roots are like terms with other square roots, cube roots with other cube roots. So in part B, we can see that we have a square root, a cube root this time, of 3. So 10 cube roots of 3 minus 4 cube roots of 3 is 6 cube roots of 3. We just again subtract the coefficients. Okay, so we're looking for the same index and we're also looking for the same radicand, so the 2 5s or the 2 3s. So now in part C, you should notice I have a 2 root 5 and a 6 root 5. Those two get added together. So what they did is they rewrote them together like that. And then for the 8 root 3, we have a minus 3 root 3. And so when we put those together, 8 root 3 minus 3 root 3, we can combine their coefficients. And so we end up with having an 8 root 5 plus a 5 root 3, and those cannot get combined. Root 5 and root 3 are not like terms, and so we don't want to add those together. Okay, so those are some rules for adding and subtracting radicals, and we'll practice a couple on the next page. All right, so on page 2, let's look at the try these and work on a few of those together. Do you see any like terms in part A? Hopefully you notice that we have a 2 root 7 and a 3 root 7. And so we can add those together and make 5 root 7. But what do we do with that 2/3? We don't do anything. We just write it at the end or in the beginning. Doesn't really matter. Okay, so 5 root 7 plus 2/3. Okay, and in part B, we have some more like terms that I see. I see a 5 root 6 and a minus root 6. Really, that's minus 1 root 6. So 5 root 6 minus 1 root 6 would be 4 root 6. Okay. Then I have 2 root 5 plus 7 root 5. Together, I can make that 9 root 5. Okay, so 4 root 6 plus 9 root 5 would be our final answer. Now, for part C, I see a 2. I see a 2 root 2, a root 8, and a 3 root 2. There's kind of a lot going on here. Well, I do notice the 2 root 2 and the 3 root 2. Those can definitely go together. But what I really want to focus on this one is that root 8, because the root 8 is not in simplest form. Sometimes you have to break things down first. So I would like to do that before I add everything together. So I'm going to move off to the side here. Remember, the square root of 8 can be broken down into 2 times 4, which is 2 times 2. Remember, you can circle if you have doubles, and then pull that out to the front. So the square root of 8 is actually 2 times the square root of 2. So I've got 2, then I've got a 2 root 2 that we already had, Then the root 8 is also another 2 root 2. And then we have 3 root 2. Now I want to combine everything together. So 2 root 2 plus 2 root 2 is 4 root 2, plus 3 more makes 7 root 2, but we still have that whole number 2 that doesn't have a radical. And so then that would be our final answer. So you might have to break down the radicals first before you can combine like terms. So you want to make sure you do that and always have your final answer in simplest form. Okay, we'll take a breath. We're going to skip over the kite problem. If we were in class, we would do it. It's a little bit of Pythagorean's theorem. I know we could do it, but it's a little much to try to do on your own right now. So we're actually going to go into example B now on the next page. And we're going to work with the exponents that are fractions, but remember, those turn into radicals. So let's review that rule very quickly. Over to the side here, it says recall that you can write a number with a fractional exponent as a radical. So if we have a to the m over n power, remember that m over n becomes the power and the root. So the m is the power, n is the root, so it becomes the nth root of a to the m power, which really can be written either way. You can write it that way or you can write it that way, depending on what's easier for your problem. Okay, so that's what we're going to work on next. So in the try these B, it says consider the sum, and they're written with powers of 1/2. Okay, so remember, a 1/2 power is equal to a square root. Okay, so anything to the 1/2 is going to be equal to the square root. So we're going to do that first. So 64x to the 9th to the 1/2 power is really the square root of 64x to the 9th. Okay, and then the same thing with the 16x to the 9th to the 1/2, that's the square root of 16x to the 9th. Okay, now we can't add these yet, they're not like terms. Okay, so we need to have exactly the same expressions in the radicals in order to add them. So what we're going to do next is simplify them a little bit. So the 64, of course the square root is 8, so that's going to come out. But if it's x to the 9th, remember with variables, you can circle pairs, so there's 2, there's 4, there's 6, there's 8, there's 9. So we can pull out 4 pairs. So that means x to the 4th is going to come out to the front. And you have one little x left inside. Okay, so we simplified. Let's do the other one now. The other one should be easy because we know 16 square roots out to 4, but we just worked on the x to the 9th. We know that's x to the 4th root x. So guess what? Now we can do the sum. So 8x to the 4th root x plus 4x to the 4th root x can be combined. It's perfect now because we have the same radical. It's a square root of x. And in this case, because we have polynomial coefficients, they have to be like terms also. And so we have 8x to the 4th and 4x to the 4th. So we can combine this one. So if I do 8x to the 4th plus 4x to the 4th, remember when you add polynomials, you add their coefficients. So that's going to be 12x to the 4th. And then if I have root x, I just have root x because remember the radical just comes along. We just add coefficients together. So our final answer, 12x to the 4th times the square root of x. Okay, so in the next page, we actually have all of your practice problems. Okay, there's quite a few of them. So we're going to do those, a lot of those in class, but I am going to have you try those on your own as well. So I know it's a lot of problems, but it'll give us something to practice in class, which is really good. So the check your understanding is 3 through 7, but there's 2 questions for 3 through 6 each, which is good practice. And then the lesson practice, of course, as well. And again, you can check your answers online. I have posted the finished copy. And then any of these that you want to do in class, when you see me, we will do in class. So that will be it then for lesson 3-1. Have a great day.